Welcome back, Algebra 1. This is the 1,4E notes, and it's very similar to what we did in 1,4D. The only difference here is we're going to be plugging some numbers in before we go through our negative and zero exponents. So let's just review what we did in 1,4D. So first of all, with number 1 in your bell ringer, our first goal is to recognize the negative exponents and then move them. So up top I have m to the negative third. That needs to be moved to the denominator. And on the denominator I have n to the negative 5. That needs to be moved up. So let me slide this over. You can see my work here. So when we do that, 2 to the third, n to the fifth, again, when that comes up top, that 5 becomes a positive. And then when the m to the negative third goes to the bottom, that again becomes a positive 3. The last thing that we need to do here is the 2 to the third. So 2 times 2 times 2 gives you 8. So there's your final answer for the first bell ringer. Second bell ringer, the first thing we had to do was there was no fraction. Since I recognize there's negative exponents, I have to make a fraction first so that I have a place to move my negative exponents to. So we move the 6 to the negative 2 down. That would become 6 to the positive 2. And g to the negative 4, that gets moved to the bottom and becomes a positive 4. So here you go. You can see my work now. K to the fifth and w, since those already had positive powers, they stay right where they are. 6 to the negative 2 gets moved to the bottom, 6 squared. G to the negative fourth moves to the bottom, that's a positive 4. Same thing in the last problem. We have this 6 to the second power. 6 squared, 6 times 6 is 36. Again, that stays on the denominator, and there is your final answer. Alright, so what we're doing here. Here's your two steps. It doesn't matter what order you do them in. You can write the expression with positive exponents and then plug in your values, or you can plug in your values and then write them as positive exponents. That's entirely up to you. I am going to go through and plug in my numbers first, because sometimes when we have negative exponents in the problem, our variable might be negative, which will then give us a double negative, and it'll move it right back to where we started from. So sometimes we don't really need to do that, that step of moving it around. So that's why I like to substitute my values in first. But let's just jump into some examples here. So first one. Let's say x is negative 5, right? So I'm going to use red for that one, and I'm going to plug in negative 5 anywhere I see an x. So here's negative 5. Raised to the power of negative 2. Now you could have moved that x to the negative 2 down to the bottom first, but again I'm just going to save it for my next step. So here I recognize I have a negative power. Since there is no fraction, I'm going to make it a fraction over 1. Circle whatever the problem is. So my problem is the negative 5 to the negative 2. And again, it's a problem because it has a negative 2 as the power, not the negative 5. That has nothing to do with the problem. So then we move that down. So negative 5 to the second power. Now again, the negative 5 does not become positive. The only thing that changes is going to be your exponent that was a negative now is a positive. Now since we moved that out of the numerator, there's nothing left in the numerator, but we can't just leave it blank. We need a filler, so there needs to be a 1 there. So then, in your calculator or in your head, negative 5 squared, negative 5 times negative 5 is 25. So that is your final answer for example A. Example B, here we go. I'm going to plug the numbers in, first step. So 3, m is 2, t is negative 3. Since there was no fraction, I made it a fraction, so I put it over 1. I recognize this is the problem because of the negative exponent. That needs to be moved to the bottom. So when we move it down, negative 3 becomes a positive 2 power. And then we just go through and do this math here. So bring the 3 over. 2 squared is 4. Negative 3 squared, negative 3 times negative 3 is a positive 9. 3 times 4 gives you 12 over 9. Final answer is 4 over 3. Again, we always have to make sure that we reduce everything. Always need our final answers in the simplest form. So 4 over 3. Next one, let's do this one together. So first up, what I'm going to do with this one, a little different than the last one, I recognize that there is a 0 power. And if you remember from before, anything raised to the 0 power is 1. So I'm going to, right from the start, I'm going to say n to the negative third, w to the 0 is 1. So I'm just going to replace that with 1, which I don't actually even need that anymore. So I'm going to get rid of that here in my next step. N is negative 2. I'm going to plug that in for n. So we got negative 2. Let me use the color here. So n is negative 2. Again, I recognize that I have a negative power, so I need to make this a fraction over 1. So over 1. I like to circle whatever the problem is so I know what I'm moving and I know what's staying where it is. So negative 2 to the third power stays, or it gets moved to the bottom. Just like in that previous problem, what we had left on top is just a 1. So now we need to do negative 2 to the third power. So negative 2 times negative 2 times negative 2 gives you a negative 8. There's your final answer. D. The only difference here is now we end up with some variables in our exponents as well. So we're going to be plugging in numbers for our exponents. Same process though. A, I'll use red for 3. B is 2, so I'm going to use green for that one. And then what I'm going to do is I'm just going to replace every variable with a set of parentheses that I will plug in numbers for here in a second. So A is 3. And then B is 2, so I had a negative 2 up here and a 2 right here. Again, I see I have a negative exponent, so I'm going to make it a fraction over 1, identify what the problem is, and then move it. Slide that down a little bit. So the 2 is left up top. And then the 3 squared gets moved to the denominator. So 3 squared, 3 times 3 is 9. So there's your final answer for example D. E I have done out here, so just follow along while I go through it. Just like the last one, we have variables raised to variables. So we're going to plug in A, B, and C. And then we will go through and move some stuff around. So follow along here. All right, so C was negative 4, A is 3, B is 2, A again is 3, and B is 2. So right here when we have this 3 and 2 in the exponent like this, these are just being multiplied, so we'll multiply those together and get 6. So next step here, negative 4 to the negative 3, 2, and then like I said, 3 times 2 is 6. I recognize the problem is the negative 4 to the negative 3. That needs to be moved to the denominator. 2 to the 6th is left up top. So 2 to the 6th is 64. And negative 4 to the 3rd is negative 64. So my final answer here is just negative 1. All right, we got one more problem here. A sample of bacteria triples each month. Okay, so this is the expression right here, 5,400 times 3 to the m. This is going to model the population of, so we're starting out with 5,400 bacteria. After however many months, we're going to represent that with m. Evaluate the expression for m equals negative 2, and describe what value of the expression represents the situation. So what we're looking at is, since this is a negative 2 for the months, we're seeing what happened 2 months ago. So we're at 5,400 bacteria right now. We want to know 2 months ago, what was the bacteria? So that's where the negative 2 is there. That means 2 months prior to where we're at right now. All right, so let's plug this in. So 5,400 times 3 to the power of m. And for m, I'm going to use red, negative 2. Now remember your order of operations. We must do our exponents before we multiply. Don't do 5,400 times 3 and then the exponent. We have to do exponents first. So I recognize there's a negative exponent, so we make it a fraction over 1. Identify what the problem is that needs to be moved. 5,400 will stay right where it's at. 3 squared moves to the denominator, becomes a positive 2 now. So 5,400 divided by 9. You can break out your calculator for this one and just do 5,400 divided by 9. And when you do that, you find out that you get 600 bacteria. So 2 months ago there were 600 bacteria, now there are 5,400 bacteria. Okay, so again, if you have any questions, rewind the video, watch the problem over again, and if you still have questions, just let me know.